Good morning, everyone. As always, I hope this video finds you guys healthy. We are moving on today to hyperbolas not centered at 0, 0. So last Thursday we saw hyperbolas at 0, 0. This week we're going to see them, or today we're going to see them not at 0, 0. And on Thursday we're going to have our final assessment for all seniors that have been keeping up with the distance learning. Your last day will be Thursday. I hope some of you can stop by the office hour at least and say adios, say goodbye, and tell me what you've been up to. But so this will be the last lesson before our final assessment on Thursday. So here's what we would do if we're in class. If we're in class, I would ask you this problem or ask you this question. I'd do this just to review point slope form. So if you remember point slope form, we had y equals mx plus b. We talked about that last week and used that for the equation of these asymptotes of hyperbolas. When we do the asymptotes today, though, it's going to be easier to put them in point slope. Point slope is this: y minus y1 equals m and x minus x1, where y1 and x1 are points on the graph, right? So x1 and y1 because that's a point, and where m is your slope. Now, we're going to find slope here in a second, or you could find slope, but we're going to find it a different way. You can subtract the y's, right? Subtract the y's, subtract the x's, and divide them to find the slope, but we're going to do that from our picture. So possible equations here would be something like this: y minus 4, using this first point, equals whatever m is, and we're not going to leave, we're going to y minus 4. We're going to put a slope in there. So slope, and then x minus 2. That's one possible equation. Another possible equation would be, let's call that x1, y1. Another possibility would be using this as your x1, y1. And we'd have y minus 5 equals whatever the slope is, and then x plus 1. So if you remember, there's multiple possibilities for this point slope form. Actually, there's infinite. You can use any xy point that's on the line. You would just have to find the slope, which we didn't take the time to find here. Okay, so here's what we're doing today. All we're doing, just like we've been doing with these conic problems, is adding an h and a k. And just like with ellipses, this changes the center, right? So now the center is going to be wherever hk is. The nice thing is that all the letters do the same thing. The a value still takes you from the center to the vertex, so this is still a. The c value still takes you from the center to the focus. That's still your c. And then the b value still takes you from the center to this other side of the rectangle that allows us to make our asymptotes. Now, when you come up with the equation for these asymptotes, everything else for the vertex and the focus, for the vertices and the foci are going to be the same. But when you come up with the equations for these, we're going to use point slope form. We're going to use y minus a point equals a slope, and then x minus a point. Now, here's what's nice about these asymptotes. There's two of them, right? One with a positive slope and one with a negative slope. And although there's two of them, they share the one point, which is right there, the center. So the x1, y1 point that I'm going to use is going to be the center of the hyperbola. So this is always going to be y minus k, x minus h, right? Because that's the one point that is on both lines, both asymptotes. And now for my slope, just like last Thursday, there's a positive slope, there's a negative slope. So I'm going to do a plus or minus. And again, you don't have to memorize the b over a. We just did rise over run. But in this case, you do go up and down. You go up b, and you go over a. So that is your equation for the asymptotes. Now, if I do a vertical transverse axis, right, this was a horizontal transverse axis. If I do a vertical transverse axis, all the stuff's the same. The a, the b, the c all do the same thing. The only difference here is the asymptotes. Again, the center right here is the point that is on both asymptotes. So y minus k equals, and then x minus h. The slope for this one would be plus or minus. Here my rise would be up a units, right? But over b, okay? So rise is plus or minus a divided by b. Again, I don't memorize the a's and the b's. I look at my rectangle and see what my rise over run is. Now, The one thing I have to warn you about with ellipses, this one is pretty straightforward, H, K go in order, but kind of like how we saw with parabolas, you got to be careful. The H is there, the K is there. H is by the X value, and the K is by the Y value. All right, and just like on Thursday, remember the A value here does not have to be the bigger. The A is always under the first fraction, the B is always under the second. Another thing you can remember though, just like with ellipses, whatever number is under the X is going to move you up and down. And whatever number is under the, is going to move you left and right. And whatever number is under the Y is going to move you up and down, right? So X is left and right, Y is up and down, just like with ellipses. So if you ever get confused about which way to go, you can think about that. You do have to remember, though, our little baby formula here, which is the C squared equals A squared plus B squared. Okay, that's still in play today as well. All right, let's do a few of these. So here's the first one I want to do. I want to give you the equation here and have you list everything. I think I have this on the next page. Okay, so let's start with this piece by piece. The center, this is my H, this is my K. So it's going to be 2, -1. Remember how the signs work there? They get flipped a little bit. 2, -1. Now let's label that point. 2, -1's right. There's my center. All right, let's do the vertices. This is your A value. So your A value here is 2. So because, and you want to know what kind of graph this is at the very beginning, because X squared is coming out front. I know this is going to be a horizontal transverse axis. So my A value is going to take me left and right. Right 2 to get to one vertex. Left 2 to get to another vertex. All right, so let's label those points. Those points then, one of those points is 4, -1, and the other point is 0, -1. Those are my two vertices. The B value I can find right away from the equation. The B value is 4, so I'll go ahead and do that now. B value is 4, that's taking me up and down to the top and bottom of my rectangle. So 4, and then down 1, 2, 3, 4. All right, there's my rectangle I'm able to make. This is going to help me find my asymptotes. All right, and now to find the C value. Yeah, I'll do that in blue. To find the C, same equation from last week. The equation is C squared equals A squared plus B squared. So when you add the 16 to the 4 and you square root everything, you're going to get the square root of 20. That's plus or minus 2 square root of 5. So again, when we label these points, we want to keep them exact. When you graph them, though, you have to kind of think about the decimal equivalent. Okay, give me 1 second here because I have to plug in my iPad before I lose juice here. All right, so let's go ahead and graph those foci then. Those are going to be approximately, the square root of 20 is between 4 and 5. So we'll go out to the right, 1, 2, 3, 4, between 4 and 5. We'll go to the left, 2, 3, 4, 5. So there are my foci, and that's just an approximation. Now when I label them, I want to be exact, okay? So just like we did last week, here's my, or with ellipses. I'm starting at my center. My center is 2, -1. And because I went left and right to label my foci, I'm going to change the x value of the center. I'm going to do plus or minus 2 root 5, because that's how much I added 2 root 5 to the right. I subtracted 2 root 5 to the left, and that brought me to my 2 foci. Okay, so that's pretty much everything I need in order to sketch a graph. So let's go ahead now, sketch in my asymptotes the best you can. So one asymptote is going to go like this, through the corner of the rectangle, through the center, and then keep going up. The other one's going to go with a negative slope. That's not very good. Let's try that again. All right. So then my hyperbola is going to look something like this. I'm going to have one branch over here to the right, and then another branch over here to the left. All right, and there are my two branches. Now, for the equations of the asymptotes, again, remember we're going to do point slope form. So y minus 2, that's the y value, x plus 1. That came straight from the center, right? Because the center is the only point that's on both asymptotes. And now rise over run. For this graph, I went up 4 units over 2 units. So it's a plus or minus 4 over 2, which reduces to 2. And that's how we're going to handle our asymptotes. Again, don't memorize the B's and A's. This rise over run was up 4, right 2. So up 4, right 2. It's a slope of 2, 1 positive, 1 negative. And then the point slope form makes it really easy to come up with the equations. I don't have to do y equals mx plus b form or anything like that. Okay. Now, we're going to do 2 more. That's the only example we're going to do where I give you the equation from the start and work everything through. Kind of. What if I give you the equation that looks like this? Okay. So, this is another completing the square, just like we did with ellipses. The reason I know this is a hyperbola straight right from the beginning is, number one, I have 2 squared variables. That rules out a circle. And I know it's not an ellipse because one of those squared variables is negative. That's all I'm looking for. Okay, so let's review this. What we have to do is complete the square. I want the positive to be out front, right, because I need the minus sign to be in the middle. So I'm going to rearrange this. I'm going to put everything with the y out front. Y squared minus 64y. Okay, I'm going to put all the x stuff together. Negative 16x squared minus 64x. Hold on. I did something wrong there. Sorry. This is a 6y. Minus 6y, right? And then negative 16x squared minus 64x. And then I'm going to bring that 71 and add it to the other side. Believe it or not, that 71 or whatever, if you have a constant there, that throws people off a lot. A lot of students just forget about that 71 or if there's a constant there, okay? Now, I'm not ready to put the square yet. With the reds, I am. There's no coefficient out in front of the y squared. But remember, with a blue, if you have a number out in front, you have to take that out. You're not taking out a GCF, you're just taking out the leading coefficient. So I have to take a negative 16 out of everything in blue. That's going to leave me an x squared plus 4x. Now I'll leave myself a little room, and I still have the equals 71 over here. Okay. Now, completing the square. In red, half of the b value. Half of negative 6 is negative 3. Squared is a 9. So I'm adding 9 to the left side. I'm going to come over here and add 9 to the right side. Now be careful with the blue. You just have to be very careful with completing the square. Half of 4 is 2. Square that is a plus 4. But remember just how we saw with ellipses. It's not really, I didn't really change the left side by 4. I have to multiply the negative 16 into the 4. Negative 16 times 4 is negative 64. So if I subtract the left side by 64, I've got to come over here and subtract the right side by 64. All right. So in red, when I factor that, it's y minus 3 squared. Remember, don't waste any time actually factoring that. It's always going to factor to half of your b value. In blue, I have negative 16. This factors to x plus 2 squared. And then on the right side, 71 plus 9 minus 64 gives me 16. All right. So that's the one example we're going to do with completing the square. We're not going to do another one. You guys have seen it enough. You should be able to do it today. One last step here, though. I have to get 1 on the right side. So I'm dividing everything by 16. So my final equation here is y minus 3 squared over 16 minus x plus 2 squared over 1 equals 1. All right. This is my equation I now need to graph. This would be a good spot to pause the video and give this a shot. See if you can go to this slide. By the way, the blank notes are on Schoology. I forgot to mention that, but that's been consistent every day. See if you can't find the center, the vertices, the foci, and the asymptote for this hyperbola, and then I'll show you what you should have. All right. So if you did this correctly, the center should be -2, 3. Be careful. Remember, the x plus 2 over here gives you your h value, so it's kind of backwards here, right to left. So -2, 3. All right. My vertex, let's go A here. My A value here is 4, right, from the A squared right there. The B value is 1. All right, I'll go ahead and find the C, and then I'll put everything together. So then if I clean that up, C squared equals A squared plus B squared. That gives me 17. If I square root both sides, plus or minus the square root of 17. Okay, so let's go back and graph these vertices. Because this was a y squared out front, in my head I'm thinking my hyperbola is going to have 2 branches, one going up, one going down. Okay, that means my vertices are going to be up and above and below the center. So I'm going from the center, I'm going up 4. 1, 2, 3, 4. I'm going down 4. 1, 2, 3, 4. And those are my vertices. So those points, -2, 7, and -2, -1. All right. For my foci, go ahead and do those right now as well. I'm going up and down the square root of 17. That's a little bit over, a little bit more than 4. So they're really close to the vertices here. One's there and one's there. Now to label those, I'm starting here at my center, -2, 3. Because I went up and down to get to those points, I'm adding and subtracting to the y. So I'm adding the square root of 17, and I'm subtracting the square root of 17 to get my 2 exact foci. All right. The asymptotes, taking the b value and going left and right 1 from the center, and I'm making my rectangle. Right? So let's graph this first, and then we'll go back and find the equation. Now these asymptotes are really steep, right? They go up and down pretty quickly. There's one. The other asymptote's going to be maybe through the corner, through the center, something like that. All right. So in my graph, I have one branch up here. I'm going to make this a little thinner. All right. So one branch is up here, hitting my vertex, popping back up. So there's one branch going up, and then I have another branch here going down. All right. So there are my 2 branches. There's my graph. Now for the asymptotes. All right. Y minus k equals my slope, and this is going to be x plus 2. The slope here, positive, negative. My rise overrun here, right? I went up and down, up from the center. I went up 4. I went right 1. So my slope is just plus or minus 4. And there are my equations for the asymptotes. All right. So one more thing I want to show you really quickly here. What if I asked you to find the equation for a hyperbola with a center at -1, 3, one focus at -1, 1, and one vertex at -1, 4? So this is one of those working backward problems. You should be able to know off the top of your head that it's what the equation is going to look like. We're going to have a minus sign in the middle. It's going to equal 1. Because of the way this is set up with the center and the vertice and focus being above and below it like that, I know it's going to be a vertical transverse axis, which means I know the y has to be out front. So make it a little bit more room. I know it's going to be y minus something out front, minus, and then an x minus something in the back. Now, look at my center. Because I have the center, I know the h and k already. So this would be y minus 3 squared. This would be x plus 1 squared. Okay. Now what I have to find is the a value and the b value. I don't really care about c here. Well, I guess I do care because I have to use it to help me find the b. So from the center to the focus there gives me a c value of 4, right? From the center to the vertex right there gives me an a value of 1. So if I use my formula, c squared equals a squared plus b squared, and I solve for b squared, I get 16 equals 1 plus b squared, and what I end up getting is a b squared value of 15. Now, because I'm not finishing the graph, I don't actually have to square root it. I know that that b squared is going to go under the second fraction, so 15 right there. And I know the 1 is a squared, so that's going to go under the first fraction, and there's my equation. Again, this one we don't have to finish the graph, so we can stop there. All right, so as one example of each, guys, one with completing the square, one with just a general graph. Your homework is 10.4 day 2. As always, if you have any questions, feel free to stop by the office hour to ask them. And if not, Thursday will be our last assessment. Hopefully you guys can stop in and say hi and bye and adios before you graduate. So if you're a junior or if you did not qualify for Spurs because you haven't been participating in the distance learning, we will do a few more lessons over the next week or two. So